Hello everyone. In this video we're going to be doing the pre-response for chapter 3 in your packet. Before we start, I wanted to address the AP sessions that College Board is starting to do every day. I think after we get through our review of each chapter by the end of next week, we are going to be relying on those more because I watched it today and I thought it was very beneficial. And you've already heard me explain everything, so I think it would be better for you to hear someone else and see. And these are people that write the test, or not write the test, but they grade it and they've done it for years. Honestly, they're much more knowledgeable than I am, so I think it would be a great resource. So as we're reviewing, what they're going to be doing is finishing chapter 11, which we did, but you could go ahead and watch those to make sure you got it all. And then they're going to also be doing chapter 12, even though it won't be on the test. So I think that's very, very, very beneficial to actually finish all of AP Statistics curriculum, because honestly, if we still have school left, because I have no idea when the actual AP test is, we might do chapter 12 anyways. So if you have the time and the ability, I would suggest going ahead and tuning into those, because we will start to use them after the end of next week. But let's go ahead and get started on this one. So it says each of the 25 adult women were asked to provide her own height, y in inches, and the height x in inches of her father. So what that means is they're trying to determine, does the height of a father help predict the height of a woman, right? Is there some correlation between these two things? And the scatter plot below displays the results. Only 22 of the 25 pairs are distinguishable because some are the same, and the equation of the least squared regression line is that equation. So they give you your least squared regression line, and we know this should be the y-intercept and that should be the slope. And the first part says draw the least squared regression line. So you have to be very careful about just estimating. Okay, well 35.1 is the y-intercept, and estimating that slope, trying to make it go through the points. What they're going to grade is, did you actually find 2 points and draw a line through those points? So what that means is, I'm going to do the work for part A up here. So using your least squared regression line equation, to get a good line, we need to get 2 points that our line's going to go through, and draw a line through those 2 points, and you have to show the work for that. So you could pick any, but now it needs to be kind of within the range of the data. Okay, I would be careful about picking something way over here. I mean, we know the y-intercept, so that could help you too, but I would pick 2 points that are close to this range of data. So let's see. If you notice, it's going by 2's, and the first point is at 62 for x. So you'd probably be fine if you pick 60. I'm going to pick 65. And I'm going to get the y hat that goes with that. So I'm going to plug that into my equation. Times 65. And then you're going to get what that is, which I put up my calculator. Give me 1 second to type that in. And that would be 35.1 plus 0.427 times 65. And it should be 62.855. So my y hat should equal 62.855. So your first ordered pair that we're going to use to get a good line is 65, 62.855. And now we can get another, you need another one. Or we can go ahead and plot that if you want. So 65, well this is 62, 64, 65 would be like in the middle, and then 62 would be about right there. Right? Oh wait, no, this is going by 2, 4, 6, 8. Yeah, so never mind, 62 should be up here. 62.8, which is almost 63. Dang it, cross that off. Okay, it should really probably fall right on top of that point. But if you have your work, they're not going to be too nitpicky. Now I was off, but, and then we need another point that would fall in our graph. So I'm picking any x value that looks like it falls within this range. I'm going to go ahead and just pick, what is this? 76. So when x equals 76, y hat equals 35.1 plus 0.427 times 76. So I'm going to get what that is. So I'm going to go up, highlight that, and then change it to 76. And it's 67.552. So that ordered pair would be 76, 67.552. So I'm going to go over to 76, up to 67, which would be about right there, 67.5. So now we know our least squared regression line should go through those 2 points. And now if you wanted to kind of, because now if I didn't do it exactly accurate, it might not be exactly, so I wouldn't lean too much on that y-intercept, but it should technically also go through 35.1, which this is scaled differently. So you know what, I wouldn't even worry about that. I wouldn't actually, it's not going to go through 35.1 because it doesn't start at 0. So scratch even talking about the y-intercept. We're just going to draw our line through these 2 points. So they are looking that you drew the line, but this is what they're looking for more than that. Okay, so that is part A. Part B says one father's height was 67 inches and his daughter's height was 61 inches. Circle the point on the scatter plot that represents this pair and draw the segment on the scatter plot that corresponds to the residual, and then find that residual. So first it wants you to circle the point that's 67, 61. So 67 would be in between here, and then 61, so it should be that point, correct? And then it says draw a segment on the scatter plot that corresponds to the residual. So the residual is the difference between the predicted and the actual. So our actual y value is at 61, where this point is. Our predicted, if you were going to use our least squared regression line for 67, if you plug in 67 to your least squared regression line, you would get this point on your least squared regression line. So your residual is this difference right here. That vertical line connecting the point on the least squared regression line and the actual point represents the residual. So it just says draw that segment, which we did, and then we're going to actually find the value that corresponds to it. So we're just calculating that residual. So I'm going to come down here and label part B. So how do you find a residual? You take the actual y and minus the predicted y. So the actual y value for our point was 61 minus the predicted. Okay, so we need to actually get what that is, right? What is y hat when you plug in our x value, 67? So you're going to have to go over to the side, or I guess you could put it in parentheses if you want, but it'd probably make more sense if I go over to the side. And my y hat is going to equal 35.1 plus 0.427 times my x value, which is 67. And if you type that in, well, there it goes. Change my x value to 67. Oh, I deleted the multiplication. And it's 63.709. So my predicted value, 709. So 63.709. Now you can subtract 61 minus 63.709 is negative 2.709. So it doesn't ask was it an over and under estimate, but we can tell just looking at the graph or looking at our residual that means we had an overestimate because our residual is negative, because we predicted a higher y value than the actual y value. Okay, so then part C says Suppose the point 8471 is added to this data set. Would the slope of the least squared regression line increase, decrease, or remain about the same? And then it says, would the correlation increase? And it tells you shouldn't be using a calculator, so you're not actually calculating. So let's go ahead and put that point on our scatter plot. The point 8471, so 84, and then 70, here 71 is about right there. So if you notice, did I do that right? Yeah, it is going by twos. Okay. I don't know. The thing I had over here was different. Oh, and you can't even see that. There we go. So if you notice for slope, it is not pulling it down that much. I understand that this point is a little below, but it is so close to the line that it shouldn't change it that much, right? Now, it's not on the line, but it is very close to this pattern. So the slope shouldn't change at all. If you were going to add that point and calculate the new slope, that line's going to be basically the same line. Maybe the slope would decrease a little bit, but that 1 point alone probably wouldn't pull it. Now, if it was way down here, then yes, it would pull it down. Or if it was way up here, it would pull it up. But that's close, so we're going to say the slope would actually remain about the same. Now again, it might change a little bit, but that's why it said about. So we'll say slope of the, and you can use the abbreviation LSRL, would remain about the same. Because the point is close to our least squared regression line. Because the point is close to the line. So it's not going to really pull it down or up. So then if that point is close to the line, what does that mean for the correlation? Would it increase, decrease, or remain about the same? So now we have another point that falls really close to that line. So what does that mean for the correlation? That there are more points that this line is close to. So it's increasing that correlation. It's giving us more data sets that this line is very close to. So I hope that makes sense. I don't know how else to describe that, because now we have more data that's closer to the line. The correlation is going to increase. So that's what I'm going to say. Correlation would increase because now we have more data closer to line. Okay, so I hope that helps. That is it for that one. I know there wasn't a whole lot of practice in here, but there is some more on your online assignment, so make sure you're working through those, because it is due Friday, and your last chance to do a Zoom conference to ask me questions is tomorrow. And I will be doing Chapter 4 AP questions next.